Something massive is hurtling through our solar system right now, and in just hours, it's going to completely vanish from sight. Not because it's leaving, but because we're about to lose the ability to see it at the most critical moment of its journey. And when it reappears, if it reappears, everything we thought we knew about visitors from deep space might need to be rewritten. What I'm about to share with you isn't science fiction. It's happening right now, October 30th, 2025, as you're watching this. Every major observatory on Earth, every space agency, every astronomer worth their salt is focused on one thing: a 3 billion-ton mystery that's about to pull off the greatest disappearing act in astronomical history. And the timing? It's either the worst cosmic coincidence imaginable or something far more deliberate than anyone in mainstream science wants to admit. Picture this: it's a quiet night in the Chilean desert, July 1st, 2025. The Atlas telescope, that's the Asteroid Terrestrial Impact Last Alert System, is doing its routine sweep of the sky, hunting for potentially dangerous asteroids. What it finds instead sends shockwaves through observatories worldwide within hours. An object, faint but unmistakable, tearing through space at over 137,000 miles per hour. Now, that speed alone should tell you something's wrong. Nothing in our solar system moves that fast naturally. The sun's gravity should have slowed it down over billions of years. But this thing, it was screaming through space like it had somewhere urgent to be. The calculations came back within hours, and they were undeniable. This object didn't belong here. Its trajectory traced back not to our asteroid belt, not to the Kuiper belt, not even to the distant Oort cloud. It came from another star system entirely. They designated it 3I, Atlas, the 3, meaning it's only the third confirmed interstellar visitor in human history, the I standing for interstellar, and Atlas for the telescope network that spotted it. But here's what the press releases didn't emphasize. Finding this object when they did was like finding a needle in a cosmic haystack while wearing a blindfold. Sam Dean, an amateur astronomer who went back through the data, discovered something troubling. 3I, Atlas had been there all along, passing in front of the galactic center where the dense star fields made it nearly invisible. It was almost as if it had been deliberately taking a path that would make early detection as difficult as possible. Now, let me put this in perspective. When the first interstellar object, Oumuamua, blazed through our solar system in 2017, it caused an uproar. Here was proof that objects could travel between star systems. It was elongated, tumbling, and accelerated in ways we couldn't fully explain. Scientists argued for years, was it a cosmic dust bunny, a hydrogen iceberg, or, as some whispered, something artificial? Then came Borisov in 2019, and everyone relaxed. It looked like a comet, acted like a comet, and aside from coming from interstellar space, it was refreshingly normal. Case closed, right? Interstellar objects are just regular space rocks that got ejected from other star systems. Nothing to see here. 3I, Atlas shattered that comfortable narrative like a sledgehammer through glass. First, there's the speed. While Oumuamua peaked at about 87,000 miles per hour, 3I, Atlas is moving at over 200,000 kilometers per hour and still accelerating. That's not just fast, that's suspiciously fast. Then there's the trajectory, its orbital eccentricity. Think of it as how stretched out its path is measured, an astronomical 6.137. That's nearly double Oumuamua's 1.2 and almost twice Borisov's 3.4. To understand what this means, imagine throwing a ball. A normal throw creates an arc that's like a typical comet's elliptical orbit. Now imagine firing a bullet that's closer to 3I, Atlas's path. It's so extreme that its trajectory looks less like it's passing through our solar system and more like it's on a precisely calculated mission. But velocity and trajectory were just the beginning. As telescopes worldwide turned to study our new visitor, the anomalies started piling up like evidence at a crime scene. July and August 2025, astronomers noticed something that makes no sense. While normal comets develop tails pointing away from the sun blown back by solar wind and radiation pressure 3I, Atlas does the opposite. It develops an anti-tail pointing directly toward the sun. Dr. David Jewett and Dr. Jane Liu, using the Nordic Optical Telescope, capture images that leave them speechless. No known physics explains this behavior. September 2025. Without warning or explanation, the anti-tail reverses. One day it's pointing at the sun, the next it's a normal tail. It's as if someone flipped a switch. The reversal happens so quickly that some observatories miss it entirely. Those who catch it can't believe their instruments. But the real shock comes from the mass calculations. Based on the lack of detectable gravitational influence on its trajectory, scientists determined 3I Atlas weighs more than 33 billion tons. That's roughly the mass of a small mountain range. Yet its brightness and the way it interacts with solar radiation suggests something impossible. It might be hollow inside. Let that sink in. In nature, objects this massive form through gradual accumulation of material over millions of years. Gravity pulls everything toward the center. You get solid or loosely packed objects, but you don't get hollow ones. It would be like finding a naturally occurring soccer ball in space. The physics just doesn't work that way unless something else is going on. Then came the event that made even skeptical scientists sit up and take notice. Between September 23rd and September 26, 2025, multiple independent observatories documented the impossible. 3I Atlas decelerated. It slowed from 68.2 kilometers per second to 67.9 kilometers per second. Now, that might not sound like much, but in celestial mechanics, it's equivalent to watching a dropped ball slow down before it hits the ground. Objects falling toward the sun accelerate. It's not just a rule, it's the law. Newton's law, Einstein's law, every law of physics we know says this can't happen. The scientific community scrambled for explanations. Could it be outgassing? When comets heat up, they release jets of vapor that can act like tiny rockets. But the deceleration was too smooth, too controlled. Random outgassing creates chaotic movement. This was precision. Could measurement error explain it? Not when a dozen different observatories on 3 continents all recorded the same thing. The data was clean, verified, and undeniable. 3I Atlas had hit the brakes, and nobody could explain why. While most astronomers cautiously discussed natural explanations, one voice cut through the diplomatic language with surgical precision. Avi Loeb, former chair of Harvard's astronomy department and one of the most respected and controversial astrophysicists of our time, had been watching 3I Atlas with growing concern. Loeb had already made waves with Oumuamua, suggesting it might be alien technology, specifically a light sail or probe sent by an extraterrestrial civilization. The scientific community had largely dismissed his ideas then, but with 3I Atlas, even Loeb seemed alarmed by what he was seeing. In a series of papers and public statements that grew increasingly urgent, Loeb laid out a possibility that made blood run cold. What if 3I Atlas wasn't a comet at all? What if it was, in his words, a Trojan horse, something designed to look natural while hiding its true nature? He pointed to the anomalies, the impossible deceleration that suggested controlled propulsion, the potential hollow structure that made no sense for a natural object, but perfect sense for a craft needing maximum internal volume with minimum mass. The anti-tail reversal that looked less like a natural phenomenon and more like someone testing different operational modes. But it was his timing calculation that really got attention. 3I Atlas wasn't just passing through randomly. Its trajectory brought it to perihelion closest approach to the Sun at precisely the moment when Earth's view would be blocked. In his paper, The Acid Test of 3I Atlas at Perihelion, Loeb asked the question nobody wanted to voice: was this deliberate? As if to underscore Loeb's concerns, 3I Atlas pulled off a maneuver that defied probability. On October 3, 2025, it executed what can only be described as a precision flyby of Mars, passing within 18 million miles cosmically speaking, a hair's breadth. The European Space Agency scrambled to reorient their Mars Express and ExoMars Trace gas orbiter. What they captured was both disappointing and deeply unsettling. A slightly fuzzy white dot where something 33 billion tons should have been clearly visible. The images were, in the words of one ESA scientist, like trying to photograph a mountain and getting a picture of a pebble. But it wasn't just the visual that troubled scientists, it was the precision. Dr. Elena Rodriguez at ESA ran the probability calculations 3 times, not believing her results. For a random interstellar object to pass that close to Mars at that exact time, given all the variables involved, the odds were less than 1 in 50,000. To put that in perspective, you have better odds of flipping a coin 15 times and getting heads every single time. Yet 3I Atlas threaded the needle perfectly, passing Mars at exactly the right time and distance for what? A gravity assist? Observation? Or something else entirely? Which brings us to October 29, 2025, 11:47 Universal Time, perihelion. The moment 3I Atlas swung closest to our Sun at a distance of 1.36 astronomical units, about 203 million kilometers. For any normal comet, this would be the moment of truth. The intense solar radiation, reaching 770 watts per square meter, would either cause spectacular outgassing or potentially tear the object apart. But perihelion means something else entirely if you're dealing with a spacecraft, and this is where Loeb's warnings became truly chilling. He invoked the Oberth effect, named after Hermann Oberth, one of the founding fathers of rocketry. It's a principle that sounds almost too convenient to be true. Simply put, if you fire a rocket engine when you're moving fastest in a gravity well, like at perihelion around the Sun, you get maximum bang for your buck. A small thrust creates an enormous change in trajectory. It's the most efficient moment possible for a course correction. NASA uses this principle for deep space missions. So does ESA, China, and every space agency on Earth. And if 3I Atlas has any form of propulsion hidden in that potentially hollow structure, perihelion is exactly when you'd use it. A few hundred meters per second of delta V achievable with even modest propulsion systems could transform its hyperbolic escape trajectory into a closed orbit. In other words, it could choose to stay in our solar system permanently. Or it could redirect towards specific targets. The asteroid belt with its vast resources, Jupiter's moons with their hidden oceans, or Earth itself. But here's the cosmic joke, if you can call it that. At the exact moment when 3I Atlas could execute such a maneuver, at the precise instant when it would be most efficient and effective, we can't see it. The object has slipped behind the Sun from Earth's perspective, hidden by 1.4 million kilometers of blazing plasma radiating across every electromagnetic wavelength. Our most powerful telescopes are useless. The James Webb Space Telescope, with its unprecedented resolution, might as well be pointed at a searchlight. Ground-based observatories can do nothing but wait. Even our sun-observing satellites like SOHO can only see so much, and 3I Atlas is passing through regions where solar glare overwhelms everything. The timing is either the most unfortunate coincidence in the history of astronomy, or it's not a coincidence at all. Think about it. You're an interstellar object arriving in a star system after millions of years of travel. What are the odds you reach perihelion at exactly the moment when the system's inhabited planet can't observe you? Astronomical odds. Unless you planned it that way. The response from the scientific community has been fascinating to watch. NASA's official statements remain carefully neutral, using words like interesting and requires further study. But behind the scenes, the preparations tell a different story. The James Webb Space Telescope has had its observation schedule completely reorganized. Precious time that was allocated to studying distant galaxies has been reassigned to one task: find 3I Atlas when it emerges. The European Southern Observatory has put multiple telescopes on standby. China's Fast Radio Telescope, the world's largest, has been mysteriously undergoing maintenance since October 15th, with no scheduled completion date. Meanwhile, a war of papers has erupted in scientific journals. Dr. Sarah Chen at Caltech published calculations showing 3I Atlas could fragment completely during perihelion, solving the mystery through natural destruction. Dr. Mikhail Volkov at the Russian Academy of Sciences countered with models showing the object's apparent density makes fragmentation unlikely. But it's the silence from certain quarters that speaks loudest. The Pentagon's Office of Unidentified Anomalous Phenomena, usually quick to comment on unusual aerial or space observations, has said nothing. China's National Space Administration, typically eager to showcase their tracking capabilities, has been conspicuously quiet since the Mars flyby. Lost in all the speculation and controversy are genuine scientific breakthroughs. In July 2025, NASA's Swift Observatory made a crucial detection: water vapor emanating from 3I Atlas. The faint glow of hydroxyl molecules traced unmistakable signs of water ice, sublimating from the object's surface. This was huge. For the first time, we could study an interstellar object using the same criteria we use for our own comets, and what we learned was staggering. 3I Atlas is old. Not just old, but ancient. Based on its velocity and trajectory through our galaxy, scientists estimate it's over 7.6 billion years old, potentially as old as 14 billion years. That's twice the age of Earth, possibly 3 times. This object has been drifting through the darkness since before our Sun was even a cloud of gas. Yet despite eons of cosmic radiation, micrometeorite impacts, and the slow degradation of space, it remains remarkably intact. In all its observed time near our Sun, it's lost only about 2 million tons of material. That sounds like a lot until you realize it's just 0.00005% of its total mass. The surface layer we're seeing sublimate is thinner than your palm is wide compared to the object's total size. We're literally seeing just its skin, not what lies beneath. And that's what terrifies some scientists. Because after 7 billion years, what could possibly remain intact inside? Natural ices and rocks? Or something else? Something engineered to survive the eons between stars? As we wait for 3I Atlas to emerge, a different kind of chaos has erupted online. Deepfake videos of prominent scientists discussing alien theories about the object have flooded social media. Professor Brian Cox found himself battling fake videos, using his voice to spread increasingly wild theories. Dr. Neil deGrasse Tyson had to issue statements debunking interviews he never gave. YouTube has been working overtime, removing channels faster than they can pop up. But it raises an uncomfortable question: why are people so desperate to fake expert opinions about 3I Atlas? The usual UFO crowd has been oddly quiet, while these sophisticated deepfakes require serious technical skill and resources. Is it disinformation designed to discredit legitimate concerns? Or are some parties trying to prepare the public for possibilities that official channels won't discuss? The timing ramping up just as 3I Atlas goes dark seems too coordinated to be random. So here we are, October 30th, 2025. As I record this, 3I Atlas is somewhere behind our Sun, hidden in the one place we cannot look. Every telescope that can be aimed at its predicted emergence point is ready. The entire astronomical community is holding its collective breath. The European Space Agency's JUICE mission, on its way to Jupiter, has been programmed to attempt observations in November. But we won't receive that data until February 2026 due to the vast distances involved. NASA's Europa Clipper is coordinating observations. Even the Mars orbiters are being repositioned for another look. Ground-based radar arrays are sweeping the skies methodically. Amateur astronomers with sophisticated equipment are joining the hunt. It's the largest coordinated astronomical observation effort in human history, and it's all focused on one question: will 3I Atlas be where we expect it to be? When the viewing geometry finally permits observation again, sometime around November 11th, we face 3 possibilities. Scenario 1, 3I Atlas emerges exactly where predicted, following the same trajectory, perhaps showing signs of normal cometary fragmentation. The scientific community breathes a collective sigh of relief. It was just an unusual comet with properties we don't fully understand yet. Papers are published, lessons are learned, and we go back to watching the skies for the next visitor. Scenario 2. We find debris, 3I Atlas fragmented during perihelion, torn apart by thermal stresses and tidal forces. But even this normal outcome has problems. Where's the debris cloud? Where are the fragments that should be following similar paths? Our telescopes can spot objects smaller than a city bus at these distances. Total vaporization of 33 billion tons? That's not just unlikely, it's essentially impossible. Scenario 3. Nothing. Empty space where 3I Atlas should be. No debris, no fragments, no trace. Just absence. It's this third scenario that keeps scientists awake at night. Because if 3I, Atlas, has vanished or dramatically changed course, we're not dealing with a natural object anymore. We're dealing with something that used our sun's gravity and its blind spot from Earth to execute a maneuver we couldn't observe. Assuming 3I, Atlas follows its predicted path, and that's a big assumption now, the coming months offer crucial observation opportunities. December 19th marks its closest approach to Earth, though at 267 million kilometers, close is relative. That's still 700 times farther than the Moon, but near enough for our best instruments to study in unprecedented detail. Every major telescope will be trained on it. Spectroscopic analysis will dissect its composition down to the molecular level. Radio telescopes will listen for any emissions, natural or otherwise. The Galileo project, Avi Loeb's initiative to look for signs of extraterrestrial technology, has all three of its observatories ready to collect data on any anomalous atmospheric objects that might coincide with the flyby. Then comes March 16, 2026, the Jupiter encounter. At just 54 million kilometers from the gas giant 3I, Atlas will pass within range of the Juno spacecraft. More importantly, Juno carries sophisticated radio equipment designed to study Jupiter's magnetosphere. It could detect transmissions that Earth-based telescopes might miss. You might wonder why any of this matters. So what if an interstellar object acts strangely? Even if it is artificial, it's not coming near Earth. Why should we care? The answer is simple: precedent. If 3I Atlas is artificial, if it's a probe or craft from another civilization, then everything changes. It means we're not alone. It means other civilizations have technology that makes our best efforts look like stone tools. And most unnervingly, it means they know we're here. Because here's what keeps me up at night: the precision, the aligned trajectory with our solar system's plane, the perfect Mars flyby, the perihelion timing. If these aren't coincidences, then whatever sent 3I, ATLAS, didn't just randomly stumble upon our solar system. They knew exactly where to send it, when to send it, and how to ensure it could observe our system while avoiding our observation at the critical moment. As we wait for November 11th, consider what we're really waiting for. This isn't just about one strange object, it's about our place in the cosmos. Are we alone, watching a weird but ultimately natural phenomenon, or are we the watched, studying an artifact that's simultaneously studying us? The next few weeks will either confirm our understanding of the universe or shatter it completely. When 3I, Atlas, emerges from behind the sun, if it emerges, we'll have our answer. Until then, we wait, we watch, and we wonder. Because somewhere behind that blazing solar curtain, hidden from every eye on Earth, 33 billion tons of mystery is doing something. And whether that something is natural or artificial, random or deliberate, benign or threatening, we're about to find out. What emerges from behind that solar glare might not be what went in, and that single thought should be enough to keep humanity watching the skies with a mixture of wonder and warranted worry. The universe just handed us a puzzle wrapped in ice and rock, or something pretending to be ice and rock. The question isn't whether we're ready for the answer. The question is whether we have a choice. Stay vigilant. November 11th approaches, and with it, either reassurance or revolution. And honestly, I'm not sure which possibility scares me more.